Hello people, let's solve another problem. 2sum less than k. Given an array A of integers and integer k, return the maximum yes such that there exists I less than j with a of I plus a of j is equal to yes and yes less than k. If no I comma j exists, satisfying this equation return -1. See the example. Input A contains some numbers which is not sorted and k is equal to 60. The output is 58. We can use 34 and 24 to sum 58, which is less than k. So what we need to do here is we need to find two integers from this array and we need to add them, and the sum must be less than k. There may be many such values, so out of them we need to find the maximum sum which is less than k. See the second example. A is equal to 10, 20, 30. K equal to 15. In this case, it is not possible to get a pair sum less than 15. Note here, they have given some constraints. The array length must be in between 1 and 100, and the array values are also between 1 and 1000, and the k value must be between 1 and 2000. Okay, this is extended version of 2sum part 2 problem. This problem has been asked in the latest Amazon interview as well. We will follow the two-pointer technique. The detailed explanation for two-pointer is done in the another video. 2sum part 2 link is in the description. Go through that video as well. Okay, let's see the algorithm for two-pointer technique. We need the arrays to be sorted, so step 1 is sort the array. Next, we need two pointers left and right and initialize them with 0 and last index respectively. For the iteration, we need one loop, let it be while, and the condition is left less than right. First, let's compare the sum of these two elements with the target. If it is less than the target, then we update some value to yes. Here yes will track the max sum less than k and increment the left pointer. If sum is more than k, then decrement the right pointer and finally return the result. Let's trace this algorithm with one example. Here input array contains 34, 23, 1, 24, 75, 33, 54, 8 and the k value is 60. First, step 1 is to sort the array. Let us initialize the variable s to -1 to track the sum less than k. On the first iteration, the left pointer is pointing to the first element and the right pointer pointing to the last element, and we will add these two numbers and check whether it is less than 60. Here 76 is greater than 60, so decrement the right pointer. On the second iteration, we will add 1 and 54 and it is less than 60, so update yes with 55 and increment left pointer. Incrementing left pointer is to check if we can find some more than 55. On the third iteration, sum value is 62, which is greater than 60, so decrement right pointer. On the next iteration, the sum is 42 and we already have 55 as the sum, so s value remains the same, that is 55, and again increment the left pointer. On the fifth iteration, we got 57 as the sum. It is greater than the previous sum, and now s becomes 57 and increment the left pointer. On the next iteration, we got bigger value 58, so update yes with 58 and again increment left pointer. On the seventh iteration, sum value is greater than 60, so decrement right pointer. On the eighth iteration, the two pointers collide and while loop breaks, and finally return the final yes, which is 58. Let's code this now. First, let's check few constraints. Initialize yes with -1. It will hold our max sum less than k. According to the algorithm, let's sort the array. Initialize the pointers. Run a while loop to iterate the array, and let us check if sum of first and last element is less than k. If so, update the s. And increment the left pointer, or else decrement right pointer, and return the sum. Let's run the code and submit. If you like this video, like, share and subscribe. Thanks for watching this.